Welcome to this physics tutorial. We hope at the end of this video you are going to gain some insight on how to attempt such question. This question comes from the topic forces and Newton laws of motion, that is physics 1. So I hope it's going to help you to prepare for your next test and exam. So let's read the question. It says, find the tension in each cable supporting the 600 Newton cat burglar in figure. So if you look at this diagram, you can see the cat burglar as a weight of 600 is supported by weight of 600 Newton, and there are two tensions acting on the cat burglar. There's one on the acting on this rope, so we can give it a name T1, and there's another tension acting on the rope on the right hand side, and we can name it T2. And if you check carefully, T2 make an angle theta which is 37 degrees, and with T1 it doesn't make an angles. So what you're going to look at or to do at the first, we are going to write the data that you are provided with. It is more important to write the data that you have so that you can know you can have a good plan to solve such question. So the first thing we know, we are given weight which is 600 Newton, and we also have theta, and it is given to be 37 degrees, and we are also given tensions T1, and we also have tension T2. So now if you look at T2, it makes an angle of 37 degrees with the surface, so it means it has two components, x and y components. So the first thing that you are going to do is to write the components of T2, components for T2. Okay, so if you look at T2, in the x components is T2x. In its x components, it is going to be the magnitude of T2, which is T2 cos 37. Remember, it is in the x-axis, so we are going to say cos theta, and theta is 37, and T2 is going to be the magnitude of T2 sine 37. Sine 37. Now it is sine instead of cos. It is sine because you are looking at the y component. So once we have written the components of T2, the next things that you need to do is to write the forces at equilibrium. So we write forces at equilibrium. So this is the equilibrium symbol for, used in chemistry or in scientific field. So now if you look at if you want to look forces at equilibrium, we are going to look at horizontal forces, meaning that forces on the x-axis, and also vertical forces. Right? So now when we look at horizontal axis or horizontal forces, we have T1, which is on the x-axis. We're going to say T1 is in equilibrium with T2x because all of them are on the x-axis. And if you look at the vertical forces which are in equilibrium, we have T2y. T2y is in equilibrium with the weight, and so that makes T2y to be 600 Newton because we have been told that the weight of the cat burglar is 600 Newton. So once we have known the forces at equilibrium, then from here it can give us a clue on how to solve for the value for T2. So we can then say you can then proceed to solve T2. Okay, so that's our third thing that you are doing. So how do we solve T2? We can come and write T2y is equal to 600 Newton. T2y from here is 600 Newton. Then what is the value of T2? From the components of T2, we have T2y, this one here, is equivalent to or is equal to T2 sin 37 degrees. So we can then say T2y is equal to, let me put this so that it doesn't mix up. This T2y is equal to 600 Newton, and T2y is equal to T2 sin 37 degrees. So instead of writing T2y, we can replace it with this one. So you can say T2 sin 37 degrees is equal to 600 Newton. All right. So to get the value of T2, then you have to divide both sides by 6 by sin 37. Sin 37 also this side by sin 37 degrees. So that brings the value of T2. If you divide 600 Newton with sin 37, that gives us a value of 997 Newton. Okay, so that's how you solve for the value for T2 or the magnitude. So if one to calculate for T1, I'll use another pen. In this case, let me use black pen. So let's now solve. So solve T1. Okay, so we know T1 is equal to, from the equilibrium forces, is equal to T2x. So but T2x, the components of T2x, we are given here to be T2 cos 37. So we're gonna say T2x is given to be T2 cos 37. So it's T2 cos 37, T2 cos 37 degrees. So from there, we can then proceed and say, instead of writing T1 is equal to T2x, we can say then T1 is equal to T2 cos 37 degrees. And we already have the value of T2, so we can say then T2, which we found to be 997 Newton, we multiply by cos 37 degrees, and that one will give us a value of 796 Newton. We just substitute. So at the end of the day, you can then say that, okay, therefore T1 is equal to 796 Newton and T2 is equal to 990 Newton, right? So this is how you attempt that question. The first thing to know is write the components of each, like T2, and that one will be easier because you have the angle that the T2 make with the ground, and after that you write the equilibrium forces, all the forces which are at equilibrium, and for there it's much easier to calculate or solve for T2, and then you solve for T1. So I hope this one help. If you are getting challenges with solving such question, I hope this one now help you to solve the question. I'm going to proceed with this question number 3. Is still from the topic forces and Newton laws of motion, and the question read: a traffic light weighing 100 Newton hangs from a vertical cable tied to two other cables that are fastened to a support as in figure. The upper cables make angles of 37 degrees and 53 degrees with the horizontal. Find the tension in each of the three cables. So if you look at this figure, we have two cables, three cables. We have T1, tension of the first cable, and we have this cable, and we have this cable. Now T1, the one on the left hand side, make an angle of 37 degrees with this surface, this angle, and also T2 make an angle of 53 degrees with this angle. T3 is in the vertical, you can see. So it means that each of these tensions on each cable is going to have its components on the x-axis and the y-axis. So the first thing, as usual, we write our data. So we have T1, we have T2, and we have our T3. And then we have theta. Theta 1 is equal to 37 degrees, and theta 2, theta 2 is going to be 53 degrees. So the question is, find the tension in each of the three cables and we have been given a traffic light weighing 100 Newton hangs. So this traffic light, the one in red, yellow, and blue, this one has a weight of, so weight is 100 Newton. So it's hanging, so it's in the vertical component. So as usual, we are going to, the first thing we are looking at the components of T1 and T2. So let's look for T1. So T1x, this one is going to be the component of T1 cos 37, which is cos theta, while T1 in the y component is going to be T1 sin 37 degrees. While for T2, we are going to have T2x is going to be the magnitude of T2 cos 53 degrees, and T2 in the y component is going to be the magnitude of T2 sin 53 degrees. So from here, we can look at the forces at equilibrium, and we can see T1 in the x component is in equilibrium with T2x, and the one for horizontal. So T1x is in equilibrium with T2x. These are equilibrium forces. So these are equilibrium forces. Okay. So this part we are done with it. And you can see T1y plus T2y is in equilibrium with the weight, because all these are vertical equilibrium forces. All the one in the y are vertical equilibrium forces, and T1x is in equilibrium with T2x, and those are horizontal forces. So from here, we can solve for horizontal forces. So we can solve for T1, and we can say solve T1. Okay. So we see here T1 x is equal to, we come here and write the components of T1x is equal to T1 cos 37 degrees. All right, I'll push a little bit. And then we say T1 is equal to T2x. T1x is equal to T2x. And we know T2x is equal to magnitude of T2 cos 53 degrees. So it therefore means T1, then T1, which is T1 cos 37 degrees, is equal to T2 cos 53 degrees. And because we are solving for T1, we divide both sides by cos 37 degrees, cos 37 degrees. This one cancel, and T1 is going to give us 0. Let me check with the calculator. So we have cos 53 divided by cos 37, and that one gives us a number of 0.7536, 0.7536 T2. So this is the value of T1. Okay, and then we can now solve for vertical components, and for vertical components we have this one here. Okay, so for vertical components we're going to say T1y plus T2y is equal to weight, and weight in this case we are told is 100 Newton, and T1y is T1 sin 37. So T1y is T1 sin 37 plus T2y is T2 sin 53 degrees is equal to 100 Newton, right? But T1, we have determined its magnitude and is 0.7536 T2. So instead of writing T1 since 37, we are going to say, I'll put this one here, and we are going to say 0.7536 T2, because that is the T1 here, T2, but T1 we told T1 sin 37, so we're going to say 0.7536 T2 sin 37 plus T2 sin 53 is equal to 100 Newton. Oh, we are running out of space, and I'm going to wrap this point here so that we can have more space, right? So I hope during this time we are trying to figure how we came to that point. Okay, I'll write until here because we are trying to create more space so that we can do it. Okay. Okay. So now this is what we have. So we have, if you check, okay, let me write it properly, 0.7536 T2 sin 37 degrees plus T2 sin 53 degrees is equal to 100 Newton. So if we check, T2 is common in the left hand side, so we can put it outside and say T2 in bracket 0.7536 times sin 37 degrees plus sin 53 degrees is equal to 100 Newton. And we put this one here. So if you multiply everything here, we're gonna have T2, we have 0.7536 times sin 37 times sin 53 is equal to 100. So it's give us, we're gonna say 1.2521 T2 is equal to 100 Newton. To remain with T2, we divide both sides by 1.2521 and divide these sides by 1.2521. So this one cancel each other, and this gives us T2 is equal to 79.87 Newton. So this is the value for T2. Okay. So once we find the value for T2, we're gonna go back and solve for T1. Okay. So I'll try to wrap and create a space again. So let me just take here. So you're gonna wrap this point again to create space. You see, it's a little bit tricky. And you need to take time to solve such questions. Okay. So let me take back the pen. So we say that T2 T2 is equal to 79.87 Newton, and then our T1 was equal to 0. This one here, 0.7536 T2. So we can say that our T1 then is equal to 0.7536 times T2 is 79.87 Newton, and that one gives us a value of 61 Newton if you round off. So this is our T1. So at the end of the day, we are going to say our T1 is equal to 61 Newton, T2 is equal to 79.8 Newton. Okay, that's how we determine the value of T1 and T2 in this equation. So the first thing that you need to do, this question needs you to look at the components of each and every tensions on the cable and how does each tension contributes to the weight of 100 Newton. So the first thing you need to do is to write the components of each and every tension based on their theta that they make within the surface. So you write both in the x component and also in their y components, and then the second thing you need to do is to check the forces which are at equilibrium. So all the forces, be it tension on the cable 1 or T2, all in the x components are going to be at equilibrium with each other. And then you look at what we call the vertical equilibrium forces, meaning that the forces which are at equilibrium, so they are going to be the sum of the tension T1, T2 in the y components must be at equilibrium with the weight, which is 100 Newton. And from there, you look at forces which are at equilibrium, and then from there you solve it. Okay. So if you have any question, further clarification, you can drop it in the comment section, then we'll attend it there. If there's any part that you need more clarity on. Yeah, I hope this tutorial helped you to prepare for your next test or next exam, or for proper understanding of how such problems can be attended. Okay, I hope this video helped you, and thank you for watching. Welcome. Hey, remember to subscribe, like the video, share with friends, and also click the notification bell so that when we post new videos, you can be notified. Come back and watch to help you succeed in your academic journey. Thank you.